China didn't go to the moon for glory. That's what everyone assumes. National pride, geopolitical rivalry, a new space race playing out in real time, and sure, those things exist. But they're not the reason. Because if this were just about prestige, China would have stopped after their first landing. Instead, they kept going. They went to the far side. They brought samples back. They started building things no one asked them to build. What China is doing on the moon isn't exploration anymore, it's something much bigger. For decades, we treated the moon like a finished chapter. Apollo went there, flags were planted, rocks came home, the story was told, the mission accomplished, and humanity moved on to other things. But here's what most people never realized. Across all of Apollo, astronauts explored roughly 25 kilometers of lunar surface. That's it. All of it on the near side, close to the equator, on flat terrain chosen not because it was scientifically valuable, but because it was survivable with 1960s technology. And for half a century, nearly everything we thought we knew about the moon came from that tiny, carefully selected strip. The rest remained untouched. The far side, forever hidden from Earth. The South Pole, where light and shadow create conditions unlike anywhere else. The ancient impact basins where the moon's crust was torn open billions of years ago. So when we said we understood the moon, what we really meant was this. We understood the parts that were easy to reach. When people compare China's lunar program to Apollo, they call it late. The United States landed humans in 1969. China didn't put anything on the surface until 2013. But that comparison misses the entire point. Apollo wasn't built for permanence. It was built to win a moment in time. The goal was simple. Get there first, prove it could be done, bring everyone home alive. Mission accomplished. China's approach was different from the beginning. Instead of racing to a deadline, they moved in stages. First, orbiters. Chang'e 1 and 2 mapped the entire lunar surface in high resolution, photographing landing zones and studying topography in detail Apollo never had. Then, landers. Chang'e 3 proved China could soft land on the moon, becoming only the third nation in history to do so. Then rovers, U2 and U2 tested long-duration survival, navigation, and remote operations. Then sample return. Chang'e 5 brought back the first fresh lunar material in over 40 years, proving China could perform autonomous rendezvous and docking in lunar orbit. And only after all of that did they start planning human missions. No rushed timelines, no political countdown, no requirement to look heroic. Every mission was allowed to learn, adapt, and feed directly into the next. By the time China began preparing crewed landings, they already knew something Apollo never had time to figure out. What actually limits long-term presence on the moon? For decades, one entire hemisphere of the moon was effectively invisible. The far side never faces Earth. No direct communication, no Apollo missions, no samples. That changed in January 2019. China's Chang'e 4 became the first spacecraft in history to land on the lunar far side. And it didn't land randomly. It touched down inside the von Karman crater, deep within the South Pole Aitken Basin, the largest, deepest, and oldest impact structure on the moon. This wasn't a publicity stunt. It was geology. That basin formed from an impact so violent it punched straight through the lunar crust, exposing material from deep below, possibly even from the mantle itself. Then came Chang'e 6 in 2024. This time, China didn't just land on the far side, it brought material back. Nearly 2 kilograms of rock and soil from a region no human had ever touched. The first far side samples ever returned to Earth. And what those samples revealed changed everything. The far side wasn't just visually different. It was geologically different. Rock, composition, mineral structure, volcanic activity, none of it matched what models predicted. Some volcanic material appeared far younger than it should have been. According to long-standing theory, the moon, especially the far side, cooled and solidified quickly after formation. But the samples told a different story. The moon stayed geologically active much longer than anyone thought. That means internal heat persisted. Energy remained trapped beneath the surface. And that matters because a moon that stayed warm is a moon that might still hold volatiles, structural complexity, and resources buried underground. Exactly the things that determine whether staying there long-term is even possible. At some point, lunar science stops being academic because understanding the moon is one thing, staying there is another, and staying anywhere in space comes down to one word: resources. China's missions didn't just collect rocks. They revealed 2 discoveries that quietly shifted the entire conversation. The first was water, not frozen lakes or underground rivers, but water molecules chemically bound inside lunar minerals. That changes everything. Water isn't just water, it's oxygen to breathe. Hydrogen for rocket fuel, radiation shielding, thermal mass. The difference between hauling every kilogram from Earth and producing what you need on site. The second discovery was helium-3, a rare isotope almost non-existent on Earth, but scattered across the lunar surface by billions of years of solar wind bombardment. Helium-3 doesn't power anything today, but if nuclear fusion ever becomes practical, it represents one of the cleanest, most energy-dense fuels imaginable. And here's the part people miss. China isn't mining helium-3. They're not extracting water at industrial scale. They're doing something far more important first. They're figuring out where these resources actually exist, how deep they are, how accessible they are, and what it would take to use them without constant Earth support. Because you don't build infrastructure where resources are theoretical. You build it where survival can become routine. Once resources entered the picture, the moon stopped looking flat. Geography suddenly mattered. And that's why nearly every serious lunar mission today converges on the same place, the lunar South Pole. This isn't copying, it's physics. Near the poles, sunlight behaves differently. Instead of rising and setting, the sun skims along the horizon, leaving some elevated ridges bathed in near constant light, up to 90% of the lunar year. That sunlight means power, solar energy, continuous and predictable. Just meters away, deep craters remain in permanent shadow. Some of the coldest places in the entire solar system, cold enough to trap water ice for billions of years. Power and resources side by side. This is why China's Chang'e 7 mission targets the South Pole. And it's why NASA's Artemis program does too. This isn't competition over landing sites. It's convergence on the only places that make long-term presence physically possible. When you remove atmosphere, weather, and magnetic fields, the moon becomes a place of narrow advantages. Ridges that see sunlight, craters that hold ice, zones where energy and survival overlap. These aren't just destinations, they're choke points. And whoever masters them first doesn't just visit the moon, they define how everyone else will operate there afterward. Up until now, everything China has done could still be called exploration. Mapping, landing, sampling, learning what's there. That changes with Chang'e 7 and Chang'e 8. These missions are different. Chang'e 7, launching in 2026, targets the South Pole with one goal above all others. What can actually be used? The mission carries a fleet of instruments, a rover, a hopping probe, a drilling system, and a water analyzer designed to determine how ice is distributed, how deep it lies, and how consistently it appears across different terrains. This isn't data for textbooks. It's data for feasibility studies. Then comes Chang'e 8, scheduled for 2028, and this is where the nature of China's program becomes impossible to misread. Chang'e 8 is explicitly designed to test in situ resource utilization, turning lunar soil, regolith, into usable material. The mission will demonstrate melting and processing regolith, using it in 3D printing to form structural components on the surface. Not concepts, not models. Physical objects built on the moon from the moon. The lander also carries construction-capable robotics. Machines designed not just to observe the environment, but to interact with it in deliberate, repeatable ways. This is the shift. Chang'e 7 and 8 aren't science missions in the traditional sense. They're engineering missions. They're testing the technologies needed to build, survive, and operate independently. This is where exploration ends and settlement begins. When you strip away the headlines, the speculation, and the political theater, a much clearer picture emerges. China didn't go to the moon to claim territory. There are no borders to enforce, no land to annex. And they didn't go to mine resources tomorrow. Large-scale extraction is still years, maybe decades away. What China is doing instead is far more strategic. They went to control the bottlenecks of permanent presence. Power generation, where sunlight is reliable and continuous. Communication relays, how signals reach Earth when the far side blocks direct line of sight. Logistics networks, how machines, materials, and eventually crews coordinate beyond low Earth orbit. And energy access, not just what exists theoretically, but what can be reached, processed, and sustained without constant resupply from Earth. This is why their program prioritizes infrastructure before crews, systems before spectacle, and repeatability over speed. It's also why all of this feeds into something much larger, the International Lunar Research Station, a permanent modular base designed for long-term operation, power-independent, resource-utilizing, and open, at least structurally, to multinational participation, offering countries a way to operate on the moon without building everything from scratch themselves. Not ownership, influence, because in space, control doesn't come from planting flags, it comes from making yourself indispensable. It comes from building the systems everyone else will need to use. The real race was never about who got there first, it's about who stays. And right now, China is building the foundation to do exactly that.